We want to find the derivative of f of x equals 4 sine x, and then find the equation of the tangent line at the point pi over 6, comma 2. So if f of x equals 4 sine x, then the derivative function f prime of x is going to be equal to 4 times the derivative of sine x, which is equal to cosine x. So our derivative function is 4 cosine x. And now to find the equation of the tangent line at the given point, we need to find the slope of the tangent line, which we can find by evaluating the derivative function at x equals pi over 6. So the slope of the tangent line will be equal to f prime of pi over 6, which is equal to 4 times cosine pi over 6. We should recognize this cosine function value as square root 3 divided by 2, but just in case we don't, let's take a look at the unit circle. Here's the terminal side of pi over 6 radians. On the unit circle, the x-coordinate is equal to cosine theta. So cosine pi over 6 radians is equal to square root 3 divided by 2. So we have 4 times square root 3 divided by 2. This is the same as 4 over 1. 2 and the 4 simplify. So f prime of pi over 6 is equal to 2 square root 3, which should be the slope of the tangent line. So now our goal is to find the equation of the tangent line that has a slope of 2 square root 3 and passes through the point pi over 6, comma 2. So to find the equation of this line, let's go ahead and use the point-slope form of a line, or the form y minus y sub 1 equals m times x minus x sub 1, where m is the slope of the line, and x sub 1, y sub 1 are the coordinates of the point. So the equation of the tangent line would be y minus 2 equals 2 square root 3 times the quantity x minus pi over 6. So this is the equation of the tangent line in point-slope form. Let's go ahead and solve this for y and put it in sloped-intercept form. To do this, we'll distribute and then add 2 to both sides. Looks like it might be a little messy, but let's go ahead and do it. We have y minus 2 equals, this would be 2 square root 3 times x, and then minus 2 square root 3 times pi over 6. Let's see, 2 square root 3 over 1 times pi over 6. Notice how the 2 and the 6 would simplify. This simplifies to 1, this simplifies to 3. So we'll have minus pi square root 3 divided by 3. Now let's go ahead and add 2 to both sides. So we would have y equals, again, 2 square root 3 times x. I could write this as 2x square root 3, but in this form we can see our slope is 2 square root 3. So we have minus pi square root 3 over 3 plus 2, which I'm going to write as plus 2 over 1, so we can add these two terms. Notice our common denominator here would be 3. Notice the common denominator of these two terms would be 3. So we're going to multiply this fraction here by 3 over 3. So finally we have y equals 2 square root 3 times x. And then here we would have 6 minus pi square root 3 all over 3. So this would be the equation of our tangent line in sloped-intercept form. Now we'll go ahead and check this by graphing the function in our tangent line to make sure this line is tangent at this point. But to make it easier to check graphically, 2 square root 3 is approximately 3.46, and this quantity here is approximately 0.19. So if we look at the graph, the red graph is a graph of f of x equals 4 sine x. The point pi over 6 comma 2 would be this point here. Notice how the blue line is the tangent line at that point, and it does look like the slope is approximately 3.46, and the y-intercept is approximately 0.19. So this is good enough to verify that our work looks good. I hope you found this helpful.